16, 17, and 18 are the last three on this page. Has to do with distance, rate, and time. And you're going to have a couple different variations of these problems. Either you're going to just basically use that the distance is equal to rate times time, or you're going to have to use that if you're going with the wind or against the wind. It's either going to push you and make you go faster, or blow against you and make you go slower. And so on the first one it says a cyclist travels 22 miles in 2 hours going against the wind. If I think about this, rate times time equals distance. For my rate, if I'm going against the wind, I've got two different rates. The rate of the cyclist and the rate of the wind. If I'm going against the wind, I'm going to take my cyclist speed minus the wind speed, because the wind is going to slow me down and I'm not going to go as fast. The time was 2 hours. The distance, 22 miles. So what they're going to do with that equation is they're going to go ahead and get the variables by themselves by going ahead and dividing by that 2 first. And so I'm going to have C minus W equals 11. 22 divided by 2 is 11. So I've got one equation. Now the second one says she travels 42 miles with the wind in the same amount of time. If I'm going with the wind is pushing against my back, it's making me go faster. My overall rate is going to be the rate of the cyclist plus the weight of the wind, because the wind is going to make me go faster. It says the same amount of time, so still 2 hours, but this time I went 42 miles instead of 22 miles. And so again, to solve this, the first thing they're going to do is go ahead and divide by 2, and so C plus W is going to equal 42 divided by 2, 21. Now this is like those very first word problems where we had the one with the sum and the difference. Notice we already have opposites in front of our W's. So we don't have to multiply anything by anything. We can just go ahead and add our two equations together, because the W's are going to cancel out. A C plus another C is 2C. Negative W and a positive W cancel each other out. 11 plus 21 would be 32. In order to solve that, all I need to do is divide by 2. So the rate of my cyclist is 16 miles an hour. I still need to find the rate of the wind. If you remember my recommendation, use the one with the plus sign. It's going to be easier, unless you don't have any with a plus sign, but usually you do. So I am going to use the C plus W equals 21. I know my cyclist is 16. So 16 plus W equals 21. Then all I have to do is go ahead and subtract. And so if I subtract 21 minus 16, I'm going to get 5 for my answer. So the cyclist is going 16 miles an hour, the wind is going 5 miles an hour. So that's one version of this problem where we're using the formula rate times time equals distance, where we're going with the wind or against the wind, either making us go faster or slower, and we start out this way so that we can get our system of equations. Number 17, it says 2 buses leave towns 228 miles apart at the same time and travel toward each other. So I got one bus going this way, one bus going this way. Their total distance is 228. So what I'm thinking about for each of these is that the rate times the time is going to be the distance of the first. The rate times the time is going to give me the distance of the second. So it says one bus travels 16 miles an hour faster than the other. So I'm going to say that the rate of one of my buses is going to be R, right? It's actually going to be the rate of the slow one because the other one's going faster. So I'm going to say the rate of my slow one is R. The rate of my fast one is going to be R plus 16 because it's going 16 miles an hour faster, right? So here's my rate for my first one. Here's my rate for my second one. They meet in 2 hours. That means this one went for 2 hours, this one also went for 2 hours. Setting up my equation then. Well, r times 2 looks better as 2r. Plus, here I would use my distributive property. If I take r plus 16 times 2, I'm going to have 2r plus 32. That's going to equal my total distance, 228. So now I have an equation that I can solve. 2r plus 2r, 4r plus 32 equals 228. I got to move my 32 to the other side, so I'm going to minus that 32. Just to make sure I don't make a silly subtraction error, I'm going to do it on the calculator. 228 minus 32 is 196. And then, of course, I have to divide that by 4. 49. So r equals 49. R was the rate of the slower bus. The slower bus is going 49 miles an hour. The faster bus was going 16 miles an hour faster, so if I take that 49 plus 16, 65 is how fast the faster bus is going. The slower bus is going 49 miles an hour, the faster bus is going 65 miles an hour. Well, does that make sense? They both went for 2 hours. So if I go 49 miles an hour for 2 hours, 49 times 2 is 98. If I go 65 miles an hour for 2 hours, 65 times 2 is 130. If I go 98 miles on the first person, 130 miles for the second person, sure enough, they went 228 miles altogether. So yeah, that makes sense. We're going to do one more that's pretty similar to that one. And that will be the last one on this page of homework. It says 2 buses leave a station at the same time and travel in opposite directions. So again, one's going to go this way, one's going the opposite way. And it says one bus travels 12 kilometers slower than the other. That should probably say 12 kilometers per hour and has a little typo in there. Let me fix that quick. So, 2 buses leave a station at the same time, going in opposite directions. One bus travels 12 kilometers per hour slower than the other one. So this time, the faster bus's rate is going to be r, and the slower one is going to be r minus 12, because obviously if it's going slower, that's going to be the slower bus. The 2 buses are 654 kilometers apart after 3 hours. So, for the faster bus, if I take 3 times r, that is going to give me the distance, the rate times the time. For the slower bus, if I do 3 times r minus 12, that's going to give me that one's distance. So my equation, 3r for the faster bus plus 3r minus 36 when I use my distributive property for the slower bus would give me 654. 3r plus 3r, 6r minus 36 equals 654. I want to solve that for r. I need to move my 36 to the other side. Since it's a minus 36, I better make sure I make it a plus 36 when I move it over to the other side. So 654 plus 36 is 690. So 6r equals 690. When I divide that by 6, r equals 115. So the faster bus is going 115 kilometers per hour. It seems like it's really fast, but it's not miles an hour, it's kilometers per hour. The slower bus is going 12 miles an hour slower than that. So if we minus 12 from that, the slower bus is going 103 kilometers per hour. So very similar to that number 17 problem, rate times time equals distance. I like to draw pictures to show what they're doing. Sometimes you'll be going somewhere and coming back where my two distances are equal to each other. Sometimes we have a sum like we do here. But just do lots of practice problems and try them out.